digital twin now is a buzzword, and what we want to do is to unwrap the buzzword. And the definition of ISO is manufacturing fit-for-purpose digital representation of observable manufacturing element with synchronization between the element and its digital representation. That's ISO's definition in the manufacturing field and what a digital twin is. But I think this is not very comprehensive yet because it misses the insights and action in this definition. So UK National Digital Twin Germany Principles Report add a little bit more into this definition. That is, what distinguishes a digital twin from any other digital model is its connection to the physical twin. So that's a connection part or synchronization part. But based on the data from the physical assets or systems, a digital twin unlocks value principally by supporting improved decision-making, which creates the opportunity for positive feedback into the physical twin. That's 3 levels. And in the very early stage, we develop a simulation model. Simulation is basically a fundamental tool in IE, right? In system engineering, we develop simulation models and the digital models. We have physical objects, and also there are digital objects that we create in the simulation model. But the data are loosely connected or in an offline manner, and we use those data to calibrate the model. And that's a manual data flow. But now you see, if you the second phase is we use the sensors to build the digital shadow that you can synchronize the data and do the visualization of the data you connected from the physical object. But more importantly, we need to close the loop and have the information and the insights and action back, just as we discussed in the Uber example, right?